Okay, for number 25, again, similar to some previous problems that we've had, I have the same index in both radicals, so I can combine the numerator denominator into a single radical. So I get 270 divided by 5. And let me just write it like this first. Okay, and so that gives you 270 divided by 5, cube root of 54. And then x to the 20 over x, I can reduce top and bottom by 1x, so I'm left with 19, right? So x to the 19. So I need 3 of the same factor. Now 54 is 27 times 2. And there are 6 groups of 3 x's, and I have 1 left over. So that's x to the 19th. X cubed to the 3rd, x cubed to the 6th times x, that means x to the 18th times x is x to the 19th. Now why did I break it up like that? Because I need groups of 3. Okay, so here's a group of 3. How many do I have? I have 6 of them. And then this x is by itself. This 2 is by itself. And the cube root of 27 is 3. So this number is going to come out as a 3. And then this is going to come out right here, the x as x to the 6th. And then times the cube root of 2x. And that's all we can do with that one, number 25. Now it's a multiple choice, so let's look for the answer. 3x to the 6th. So that would be letter D. Okay, for number 26, I have both square roots, so I can combine them as a single radical. Now, notice I'm not going to multiply 175 and 21. I'm going to just write them like that as 2 separate factors, and you'll see why in a minute. And then x, I've got x to the 3rd in the first one and x in the second one, so that's x to the 4th. And then for the y's, I have y to the 3rd and y to the 4th, that's y to the 7th. Okay? So, move this up a little bit. I know that this is 25 times 7. And I know that this is 7 times 3. So, notice how I have a pair of 5s right here. I have a pair of 7s right here, right? Because I say pair of 5s because 5 times 5 is 25. So that comes out as a 5. This is going to come out as a 7. Okay, the 3 is going to be left inside by itself. Well, I shouldn't say by itself, but it's going to be left inside the radical. And then the x to the 4th, well, I've got 2 pairs of x squared. So this comes out as x squared. There's no more x's inside. And then right here with y, well, the y is y squared to the 3rd times y. So this one comes out as y cubed. Okay, and then I have a y left over. And so that y that's by itself, that one's going to stay inside. So on the outside I have 7 times 5, which is 35. And then I've got x squared. Then I've got y cubed times the square root of 3y. So here you can see why I didn't multiply the 175 and the 21, because it's a lot easier to break them down when they're smaller. Okay, and that's the answer right there. Alright, so for number 27, you are squaring that binomial. So remember, this is the same thing as negative 5 minus radical 3 times negative 5 minus radical 3, or square root of 3. So you use distributive property, so start off with negative 5, so negative 5 times negative 5 is 25. Then negative 5 times radical 3 times negative radical 3 is positive 5 radical 3. Then you do negative radical 3 times negative 5, which is also positive 5 radical 3. And then this one, negative radical 3 times negative radical 3 is positive radical 9. But radical 9, or square root of 9, is 3. So this one could be replaced with a 3. So then you have 25 plus 3 is 28. And then here I have two like radicals, so 5 and 5 is 10. And so there's your final answer. Okay, so 28 is another distributive property problem. I've got 7 minus square root of 2 times quantity of 8 plus square root of 2. So 7 times 8 is 56. 7 times square root of 2 is 7 square root of 2. Then you move on to the next term. Negative square root of 2 times 8 is negative 8 square root of 2. And negative square root of 2 times positive square root of 2 is negative square root of 4. But again, we know square root of 4 is 2, so this one I could replace with a 2. So now I've got 56 minus 2, so that's 54. I've got two like radicals right there. I've got 7 minus 8, so that's negative 1, so negative square root of 2. And that's your final answer. Okay, so again, you're asked to simplify and leave it in the simplest form. I know it says product, but it's actually a quotient, so that's just a typo. So let's go ahead, since they're both square roots, write them in a single square root. So this is 2x to the 12th, y to the 9th. And then this is 3x to the 4th, y squared. So let's go ahead and simplify the x's and the y's. So I'm going to have square root of 2/3. Now 12 minus 4, I'm looking at the x's, because remember when you divide, you subtract the exponent. So 12 minus 4 is 8. And then do the same thing with the y's. So I've got 9 and 2 there, so 9 minus 2 is 7. Okay, so I'm going to take out 4 pairs of of x's, and 3 pairs of y's, but I'm still going to have a y left over, right, because 7 is an odd number. So for this one, I'm going to take out y to the 3rd, but then I have a y left over, okay, because that makes y to the 6th. Over here on the x's, I forgot to write it down. I'm going to take out x to the 4th. Okay, so I have x to the 4th, y to the 3rd, and let me write it on the next line. It's kind of sloppy. So over here, x to the 4th, y to the 3rd, times the square root of 2y over 3. Now, I cannot leave it like this because I have a 3 in the denominator inside a radical. So I'm going to multiply top and bottom by 3. Okay, so it's the same thing as multiplying by 1. So like that. Oops, 3 over 3, that's 1. So I multiplied by 1 right here. Now, why did I do that? Because now I could take out this 3, because now I have a pair of 3's. I could take it out because the square root of 9 is 3. But notice it's in the denominator, so be careful about that. So I'm going to have x to the 4th, y to the 3rd over 3, because this 3 that came out is in the denominator. Okay, times the square root of 6, because I have 2 times 3, so that's 6y. And that's the simplified form of this number. Okay, so for number 30, we're looking for 3 of the same factor. So 24 is 8 times 3. And I know that the cube root of 8 is 2. So it's going to come out as a 2, and the 3 is going to stay inside. For 8 to the 13th, I can rewrite that as 8 to the 3rd to the 4th power, and that gives me 8 to the 12th. so I still have a, an extra a. And then for b to the 9th, I could write this as b to the 3rd to the 3rd power, because 3 times 3 is 9. So the a's come out as a to the 4th, and the b's come out as b to the 3rd. Okay, so I have a 3 left inside the radical and an a. So my final answer will be 2 a to the 4th b cubed times the cube root of 3a. And that's the final answer.